Good afternoon, everyone, and welcome to this eighth seminar on the seminar series Open for You. This is a series of seminars offered by the For You Plus Alliance. You know, this is an alliance formed by the 6 universities: Sorbonne University, Università degli Studi di Milano, Charles University, Warsaw University, Copenhagen University, and Heidelberg University. My name is Paola Galimberti, and I will give this presentation together with, I'm from the University of Milan, and I will give this presentation with my colleagues, Milan Janíček from Charles University, and with Jochen Apel from the University of Heidelberg. Before we start, please mute your mic, but feel free to open it if you have a question or if you have doubt or comments, or if you want, you can interrupt us anytime, and you can use also the chat to ask questions or make comments. Together, we will speak about research data management. And we will give an introduction on research data management, what is research data, what is research data management, and how and why you have to manage your data in a fair way, and why sometimes you are requested to manage your data as open data. And at the end of the presentation, we will give some example of various data repositories, subject-specific repositories, generic repositories, and institutional repositories. What we will talk about today? This is a sentence from an article of 1995. So quite an old article, but in 1995, the authors defined a scientific publication not as a scholarship itself, but as merely advertising of the scholarship. So what is the scholarship itself? If we look at the research process as an iceberg, we can see that publications are the tip of the iceberg. But the very, very important part of the research is underwater and is formed from notes, databases, video, feedback, experimental data, recording, images, annotation, and so on. So if we want to define, if we want to give a definition of research data, what is research data? Could you write, or could you try to give, open your mic and try to give a definition of research data? Is this data, in your opinion? For example, you are an archaeologist, and is this data for your work, for your research? Yes, this is data. And is this data?
Yes.
Yes. And is this data?
Yeah.
Yes. Okay, so what is research data? we can say, we should take a broad definition because disciplines are very different and research data are different for the different disciplines, but we can define research data as any information that has been collected, observed, generated, created to validate original research findings. So research data is a very important resource, and it is collecting, observing, generating, and creating research data is very time consuming. It costs a lot. So we must ensure that it can be reused first and foremost by ourselves. There are some problems with research data. First of all, data can be missed. And with the age, with the time, it is more and more difficult to access underlying data to a certain research. And data can get lost, and causes of data loss, the reasons for data loss can be different. For example, hardware failure, human error, software corruption, computer viruses, theft, hardware destruction. It can be, you can have several causes for data loss. And data can also be manipulated or altered. This is a very, very well-known case. It is a story of this psychologist from Netherlands, Apel. He was a very, very well-known scientist, and most of his research was based on invented data. And when the data manipulation was detected, 58 articles published by this author were retracted. So if he had shared his data before, he probably wouldn't have been able to fabricate fake data for so long. So these problems can be partially solved through responsible research data management. Research data management. What is research data management? It concerns the organization of your data, starting from the very beginning when you plan your research to the publication and to the discover and reuse of your data. And it aims to ensure verification and replication of your results, and permits new and innovative research line to build on existing information. A warning: research data management is not only something that affects life sciences or medicines. It applies to all disciplines, including humanities and social sciences. Funders are pushing research data management in Horizon 2020 and now in Horizon Europe. It is a requirement to develop a data management plan. You have seen in a previous seminar what is a data management plan and why it is important to plan your how to manage your data from the very beginning of your research. And participating projects are required to deposit research data in research data repositories, and to take measures to enable access for third parties. Also, national funders require to manage data in a way that they are available as soon as possible. These are the guidelines from the Deutsche Forschungsgemeinschaft. And it is a requirement to make research data available as soon as possible. But also in Italy, with our Piano Nazionale di Ripresa e Resilienza, it is a requirement that publication and data are managed according to the principle of open science and fair data. Not only funders require a specific research data management, also journals require to make data available and available in specific repository. We have here a screenshot from Nature. Authors are required to make materials, data, and associated protocols promptly available to readers. And the preferred way to share their large data sets is via public repositories. This is from PLOS. From PLOS journals, there is a chapter on data availability, and authors are required to make their data fully available without restriction, and refusal to share data will be grounds for rejection. So you see that there is a request from funders, from journals, from institutions to make research data available, and to make research data available according to a certain principle. Milan, I think the floor is yours.
So let's talk again about fair data principles, which are the main principles which define how data should nowadays look when you want to work with them and share them. These data principles came from area of natural sciences, but now they are more general, and they are, as Paola mentioned, they are really the basis for all kind of different rules. You can see here very interesting link on this slide, and you will have the presentation. There are generally 15 rules which define, or rules, it's not really rules, it's really principles. 15 principles which can be described to some extent, and here is very nice link with the SNF part when these 15 rules are described, but as you came here to listen to us, we will try to describe it for yourself in a different way. So we have seen that FAIR is for findable, accessible, interoperable, and reusable. And we will go through the letters, letter by letter, not really principle by principle, but more in a general way. Principles under F category are mostly about ability of others to discover your data. So if you are preparing some data and you want to provide them as fair data, you should describe them using rich metadata. You should be using persistent identifiers, and you should allow somehow them to be indexed in catalogs or databases. So this is really centered, these principles are centered on findability. So your data aren't just published, but they can be found. You can imagine this situation if you go to the library and you would like to find a book. You would probably use the catalog, But for a catalog to work, you need the book to be described somehow. So you enter something that you will find. So this is this part with metadata. You can imagine it in this library world like Nordic Crime Series, or it's Encyclopedia of Motor Airplanes. You don't really see the book, but you have enough information to have some idea what are you looking at. You then can find the location in a library of a book. You will find through metadata, and then you usually need some kind of very specific identification to find the books amongst all the books that are in the library. You can see something like this: 6th floor, shelf 6A, etc., etc., and then some very strange looking code, which doesn't really usually means much to end user, but if you would show it to a librarian, they would probably know the topic of the book. So if we come back to findability of data, and we still compare it with libraries. In library, the authors don't really provide the metadata, and the librarians who are experts in this organizing of the library are creating the description or metadata for you. In online world, on the other hand, the author has to describe what he uploaded himself. So this is there is some responsibility here. If we are in online world, it's our responsibility to really describe the data that we upload. You can see here there is on the right side of this slide, there are some examples of keywords somebody put to their metadata. And you see it's very, very different, very specific. And they can do it because they know what kind of data they are uploading. You can also see here the second part, that there is this identifier or some codes which help you to really receive the data and or retrieve the data. And there are some links to some other things, for example, journal article and software, which you can see in the bottom. We can say a bit more about metadata, which sounds kind of strange, but it's generally something that describes the data. Typically, you would have in most data sets some kind of title, how the data set is called, some author, usually also some keywords, subject headings, which are some predefined keywords, and identifiers. It's really important for helping the others to help your data. Authors usually have chance to choose metadata when they upload their data to a repository, and you can really make your data to be lost or to be found. Libraries can help with this part as well, because, as I mentioned, libraries are built around categorizing things and describing things by metadata. The other important part, which we mentioned a bit more, is persistent identifiers. It's some kind of sequence of letters or numbers in a specified format, which is typically managed by some service provider. What this part means is that you can't really create your own persistent identifier and say, okay, this is my thing. You usually have to use some existing service. There are a few attributes these identifiers has to have. They are unique. That means that different things have different identifiers. So you can see here an example of something that's not a unique identifier, and its name. If you would say, for example, that author of something is Carl Johansson, you have no idea which of many Carl Johanssons is the person who really created it. And unless you have some other context, which is not great if you really want to work just with the metadata themselves and not really look on the internet if there is somebody with some connection to this data set, for example. Another part, it's in the name, is that they are persistent. So these identifiers are supposed to work forever. And if they are unique and persistent, you can't really reuse identifiers. You will have a specific code for the work, and it should really work to some extent forever. They also are usually resolvable. So there is a way how to get representation of this identified object. They usually have a form of links to the service, and I will explain it a bit more here. You probably know some identifiers. Most popular in publishing is at the moment DOI, Digital Object Identifier. You can see an example of this identifier on the right side. They are used for articles, but nowadays they are starting to be used more and more for data as well. And there is some infrastructure that's allowing this, and it differs slightly from the part that takes care of articles. Another thing that can be identified, I was mentioning this imaginary Carl Johansson. So for him, it would help to have ORCID, or Open Researcher and Contributor ID. Again, you can see there are some numbers as an example, and this is personal identifier. If you know that this is the code and ORCID is the service, you would find out who this person is. There are many more things that can be identified. Of course, generally everything that you can use for more than once can have some identifier, but another developing example right now is Research Organization Registry, which is for institutions. And you can see example of some code of theirs here. It can work in a way that if you, for example, would have all the work of people who are from one institution, and everybody would say, okay, I'm not from Charles University or Karlova Universita, or many different ways how you can write one name of institution, but everybody would use this code. It would be very easy for computers, for example, to really sort this out and understand who is related to which institution. Another note here is that URL is not an identifier. It may seem often very similar, but yeah, there is this distinction of this code. So as you can see on the top, there are this example with Zenodo, but this URL that's not an identifier, yeah, there is Zenodo there as well, but it's not really, the service is just a location. Because there are some properties which we mentioned before, that these identifiers should be persistent and unique, and they should work forever and lead you to a representation. It's really important to use identifiers, not URLs, when you, for example, are creating citation of a work. And you can see just below that, yeah, sure, URLs are not identifiers, but you can use URLs inside. You can use PIDs, identifiers inside URLs. You may see here on these three examples that you always have the service, doi.org, orchid.org, ror.org, and then you have this code we have in the top part of the screen. So you really are always leading to the service, and the service will lead you somewhere. For example, one of these services is Zenodo. And so if you click on this DOI link, it will lead you to Zenodo. But the identifier is really this example with DOI.org in the address. So this is part about findability, make your data available to be found. The other part of the problem is accessibility. your data can be made available to others. In this age of internet, it's usually some very simple protocol, and you can use just web browser. But generally, FAIR principles allow some more sophisticated way. For example, you may be told to ask for permission to get the access to the data set, and it will still fulfill this accessibility principle. You just, if you know about existence of the data set, you should be able to find out how you can access this thing or what are the limitations. It doesn't really mean that you will has to have access to everything immediately on web. For this knowing of a persistent identifier of the data set should always help you, because even if it would be something that would be that wouldn't be possible to get access to, you still should get at least some metadata, so you will have idea of what this object or this data set is about. It's really, in fact, requirement, and you can receive this by this resolvable persistent identifier. There is an important rule that not everything has to be shared without limitation. The rule that usually applies is as open as possible, as close as necessary. This is also something that caused a small shift, because a few years ago, people are more talking about just open data. And now there is some kind of compromise, and the discussion is more about fair data, because there are some kinds of data that can't be shared. On the other hand, it's really nice if your data are not limited in this way, but we will talk about opening the data later. How you can achieve accessibility? In a simple way, if you publish your data in a repository, you are almost there. You can see an example from Figshare. If you notice, there is this, next to the red side button, there is download button, where you can just get the data. As I mentioned, metadata should be publicly available, always or almost always. So even though we would like to limit access for some good reasons, which you would have to explain somewhere, to your data, you still should usually publish at least metadata to have the description out there and findable. The third of the four is interoperability. So generally it means that other people should be able to use your data with their own data or in some different way. So again, just publishing and making them findable doesn't really, it's not really sure that people would be able to use something that you put out on the internet. It should be also possible to understand the data and read them generally. So one of the important things is that format should be readable somehow, and there should be some helpful documentation, not really just describing the data set, but the content of the data. And you also should use some well-known terminology. Usually it's called domain standards. If you work in a domain and there is something established for exchanging of the data, if people will, for example, in some kind of chemistry, they will describe the data in the same way, it would be much easier to make them interoperable. Two easy points for making data more interoperable is using some kind of open formats. For example, plain text is very nice format. Of course, you can't have plain text for videos or something. So the other part is that there should be tools available to really use or read your data. And if you are using something very specific for some I don't know, some files from microscopy or etc. You should try to find the format that is most used. You shouldn't really use something that only your computer can read, or you need to buy some very specific software that nobody else uses. It really stops the interoperability from happening. Another part is using the right language. We usually talk about some vocabularies. Here is an example of one topic in MESH, which is for medical sciences. And you can see that there is a very specific description of some term. And if you and all your colleagues will use this word in the same fashion, your data would be interoperable in an easier way. You can see that just opening the format is not enough by itself. If we see this example, we have something like 4 numbers. They are very open. You can read all the data that I have on this slide. And I even have some description. I say it's temperature. But the problem is that I still didn't describe the data well enough. So nobody knows, not even me, what's the context. Is this data for some patient, or was it just hot summer, or what? So you should really, these FAIR principles aren't always just about some technical checking. If you are like checking the rules, okay, it's open format, okay, everybody can read it, it's described somehow, but it really has to make sense. And it should be your goal to describe your data to make it operable and reusable. And by that we come to reusability. So generally this part is about the principle that others should be allowed to confidently reuse your data. It should be possible to trust the data. So the provenance is important, and it should be clear what is allowed to do with the data, because there may be some limitations for some kind of data. So licensing conditions is something that's tried to solve this part. How you can achieve this reusability, or not really achieve, but how you can get closer to this reusability principles. You should describe the origin of the data sufficiently. How did you get them? What are the instruments that where you get the data from? How the data were modified or processed, if they were. And people should know as much as possible about the data, and then they can reuse them in their own context. Also, this other part is this licensing. So there should be some license that describes what is possible to do with your data. And example here is on the last line of this Zenodo example. You can see there is Creative Commons attribution for international. So you know that you can use this this data, but you have to attribute it to the original. You have to make the attribution to original data set. And perhaps it may be a good idea to share the data freely. By that, we go to open data, and I give the floor slowly but surely to Jochen.
Thanks, Milan. Yeah, also welcome from my side here, from sunny Heidelberg. I just have to start the sharing. Okay, so this next part of the presentation will be on open research data, on publishing data, and why this is a good idea, at least for some data. Of course, we already heard from Milan that not all research data can be publicly released. So of course, if you deal with sensitive data, so if you work in medicine and you have patient data, there might be lots of data you will not be able to share with other researchers. or maybe you will not be able to share your raw data, but you may be able to share aggregated statistics. Or so if there's a will, there's also a way. And also you heard from Paola already that there is a lot of effort from research funders, but also from scientific journals put into open science activities at the moment, and they are really pushing into the direction of open research data. So you may sit here and ask yourself, in a sense, so why I put it as a question on the slide. So why did I write why open data? Isn't that a no-brainer somehow? Isn't it self-evident that science there are good reasons that science needs open research data? And maybe that is the case, but as you also might know and might very well be aware of, that it is not the case in most disciplines that research data are publicly available by default. Not even in cases where you don't have any problems with sensible data and stuff. So just had a look at the chat. And I want to talk about this phenomenon for a moment. So why is there such a little amount of openly available research data? And in my opinion, that has something to do really with the incentive system for scientific careers and with the way how your research is evaluated and how you really make a career in science. So because especially you as early career researchers are aware of this even more than I am, so that the currencies of science, so the things your research is evaluated against, is quite roughly put something you do with your publication. So it's really important for you to publish peer-reviewed articles in high-impact journals, or if you are from the humanities, it might be about publishing a book with a well-respected publisher. If you work in mathematics or computer science, for example, it will be important for you to be accepted for presentations at the large conferences in your field. And then it's also, of course, much about citations of your own work and what's your H index, what's the journal impact factor of the journals you published in, and all these kind of things. So at the end of the day, that is what gets you your grants, your funding, and then in the long run also the professorship you are desperately working for. And of course, this is really only a rough sketch of how the scientific incentive system really works. But nevertheless, I think there's some truth in it. And this really has some consequences. And these consequences are also related to data sharing and open data, because, and that now is even a much rougher sketch than the one before. It has consequences about what kind of research outputs are shared with the scientific community. So this image here, so the basic idea is, if you look on the left side, all these little squares you have here, they represent some kind of research outputs of your scientific work, so of your research. So this might be the results of measurements you gathered, or this you might be data you acquired while running a simulation, or this might be a piece of research software, a small script you wrote to analyze your data. It might contain negative results because some experiments didn't go the way you imagined them to go, and these might be results you will not be able to publish in a journal or something. And then you take all these kind of outputs and you condense them in various steps to some kind of, to a scientific paper at the end of the day. So that's the right, the small red dot on the right side. That's your paper, your research paper, and that is the only output typically, or in many cases, which is really published and which is made publicly available. It's a paper, it's in Nature, and that's really great for you. But it also means that this is the only thing of the things you produced which will be available to the scientific community. And the script you wrote, it will stay maybe on your hard drive all the day, and also the data. And that is really a consequence of the way scientific careers are incentivized to some extent. And of course, that's the wrong direction. It really is a pity, because it's quite obvious that open data improve science and improve research activities. So as one example, think for a minute about climate science. Of course, we have huge discussions about climate science at the moment, and about global warming and how strong the human impact on global warming is, and what we need to do, or how strong we have to cut our emissions if we want the global temperature to rise not more than 1.5 degrees, and all these kind of things. And obviously, all these kind of discussions would not be possible at all if we weren't able to create climate models which are reliable to some extent. And of course, we are only able to create this kind of climate models because we have lots and lots of climate data available, and we have weather data from all different places all over the world, and also from different times, and we are able to aggregate these kind of data in huge climate data repositories or climate data centers. And this is the basis for climate science at all. So lots of these data stem, for example, from logbooks of ships, because of course in ship logbooks, you always have an information on what the weather was like on a particular day. So this is a huge data treasure for climate research. And of course, also in other fields, open data really improves science. So here's an example from the life sciences. It's from the beginning of the 21st century, or from the end of the last century, there was a large research project going on, the Human Genome Project. So that was the project of analyzing the complete human DNA. And what was done in this field of research was that the researchers agreed to share their data openly via public database or via different public databases. Milan will show you one of them afterwards. And here it was the case that only this kind of open data infrastructure made the Human Genome Project possible. So Patrick Brown, one of the lead scientists in this, he puts it this way. So as you can read on the slide, the success of the Genome Project is in no small part due to the fact that the world's entire library of published DNA sequences has been an open access public source for the past 20 years. So if sequences could be obtained only in the way that traditionally published work can be obtained, there would be no Genome Project. So these examples quite instructively show that open data is really something which enhances scientific activities, and which can really do this also in other fields of research. And so even if it is the case in your particular field of research that data sharing is not so common at the moment, it is something which will definitely become more and more common in the future, not only because research funders, for example, are wanting this, but also because there are really a lot of benefits associated with open research data. So as you can see them here on the slide, I start on the right side. There are, of course, benefits for the research community, because when data are openly available, it's easier to find data which are useful for you and your research. It's easier to archive the data and preserve them for the future. That can enable, of course, new research by, for example, mashing up data from different data sources and then analyzing this new combined data set. Also, data can, of course, be reused in teaching, and this makes research more efficient. Of course, there are also benefits for the general public. That's on the left side. So if data are publicly available, validation is possible. So research becomes more transparent. That of course can enhance public trust in science. There might also economic benefits for that, or also opportunities to create, for example, citizen science projects. And at the end of the day, if we manage to create a culture for open data or open research data, this might enable also benefits for you as an individual researcher. So it might enable, of course, new collaborations, but it might also enable career recognition. So at the end of the day, we might be able to reshape this rather crude incentive system we have for scientific careers, which I talked about at the beginning of my part. So if we manage it, that to make research data, for example, citable by assigning a persistent identifier to them, then people, of course, can start also to cite your research data or to cite your research software or things like that. And then in this sense, you can also start to get academic credit and then career recognition for providing data for your scientific community. And you will not only be the author of this famous paper in Nature, but you will also be the author of this famous data set, which is used and reused for a myriad of other research questions. And that can really be beneficial then also for you as an individual researcher. So, and if you think there's really something in it, and you also consider that data sharing or publishing data might be an idea for you and your research, but you might have no idea where to look for venues for publishing your data, then this website here could be a good starting point. So the optimal venue for publishing your research data is not your institutional website, for example, but it really is a trustworthy data repository, or also a professional publication platform for research data. And there are websites like this one here, re3data. This is the registry of research data repositories. And on re3data, you can look up what kind of data repositories are around in particular fields of research. So you can run a search there. For example, if you work in machine learning, you can search for machine learning or for whatever, and you will then find some repositories dealing with machine learning data, and then you can click on that and get more information, for example, on here in this case OpenML, machine learning repository. There are also services in this area around. Another important website which I really could recommend is Fairsharingorg. This is a website where you can look for repositories and other databases, but also for other data-related topics, like you can look up, for example, standards like metadata standards or data policies and other kind of things there. And that is really something I could recommend taking a look at and just looking what's in there for your particular field of research. And then you might be able to find data repositories. So there are several data repositories around, and at the end of this, or in the last section of this presentation, we want to show you a few data repositories as examples, because yeah, really these repositories are not only publication platforms, but they are really also platforms which assist you in providing fair research data, because you don't, if you use a data repository for your data, you don't have to take care of any of every letter of the fair. But the repository will take care of, for example, the findability of your data by assigning a DOI to your data and all these kind of things. Roughly, there are different types of repositories around, and you have to think about which one would be a good venue for you. So at the first question, if you want to share data or deposit data to a repository, is you have to ask yourself whether you deal with sensitive data, because when you deal with sensitive data, you might be in need for some kind of access control mechanisms. And if that is the case, you must have a look for controlled access repositories where where special functionalities or mechanisms are in place to control who gets access to your research data. If you don't, or if you don't have any problems with, for example, personal data or sensitive data for some other reasons, you could have a look for subject or domain-specific repositories, which are, of course, a good choice if there are any around, because they are able to offer domain-specific or data type-specific functionalities. Or you can go for more generic solutions, like, for example, some universities offer institutional repositories, or there are also generic data repositories around which every researcher on the world can use for her or his data. So that said, I would hand over to Milan, who will show you two examples of domain-specific repositories and how these help you to provide fair research data. Stop that.
Yes. So we have two examples here of domain repositories. One of them is Lindat repository, and the other one is GeneBank. They are for very distinct domains. So let's see how they work, not only with data, but as well with FAIR principles. So Lindat, Claria, CZ is an example of a repository that's concentrating on a domain. It's Linguistic and Digital Humanities repository. It's not only a repository, but there are also some services there. This repository is built on Charles University and Faculty of Mathematics and Physics. And we will see that it's really a typical example of domain repository, because generally anybody can, from this domain, can put their data in there. We will just look on it from the perspective of the things we were talking about. So how does it help findability and accessibility and interoperability and reusability? You can see here is an example of some data set, which is very specific. It's universal dependencies, it's linguistic resource. You can notice that there is something like reference to the article. So there is connection between the article and the data, but the data are stored separately. It's not as part of the article. So they have their own life, and they can work really separately from the original article. You can also notice that languages are important here. You can see a lot of languages in description. And it makes sense, of course, because it's linguistic resource. So yeah, they really know what's important for them. And they need to describe all the languages that to which this specific resource is connected to. If I would talk about it more generally, if you have data from some domain and you will go to domain repository, you will often see that the metadata can describe your data set much more precisely than if you would go to some generic repository which has to accept all sorts of different kind of object. Another interesting part in this repository is that persistent identifier here is not DOI, which we mentioned, but it's item identifier, and it's this HTTP HDL handle. So it's very similar to DOI, but for some reasons, and they use something different. So the lesson here is that really there are many things that are persistent identifiers. They really have to fulfill the rules, but you usually don't have to, like, it's not limited to just 2 or 3 identifiers. It's more like generic concept. This is another part of this example. You can see some description here, which will help you understand what the data are about and how they were created, for example, and what are they for. Again, from the findability perspective, you have some keywords here, which help you find this data set. Specific thing in this case is that there are different versions of the data set because it's something that's evolving. This is version 2.9. But you also sometimes need to reference all the previous versions. For example, if somebody would do some work and would like to use this data set, so they will work with 2.9, but in next year, they may be version 3 or something. So you still will need to have access to this original 2.9 version because there are some articles and some works connected to it. You can't really delete it. And one of the things that repositories tend to do is like do things properly. And the last thing I mentioned before is the license. You can see on the bottom. You can read there that this item is publicly available and licensed under license universal dependencies 2.9. So they have even specific license for this kind of data, which is caused by the way how these data sets in linguistics are constructed. From the accessibility point, you can see there is a way how to preview the data. Actually, you can see the size is over 400 megabytes, so it's really big archive. You can download, or you can just have a way how to look into the data. Again, it depends on the domain if this thing is helpful or not. And you can also see the other part. There are three files. There is this big file, the main file of data. The other second is documentation. So you will have some description. You will know what you really have in this data set you just downloaded. And the third one is interesting as well. It's not very big, but it's file with tools. So they will give you something more, not just the data, but tools as well. It's another part of open science, and it allows you to work with the data in a convenient way. I mentioned you can upload into this repository if it's something that you are working in this domain. You generally can log in with your institutional credentials, even if you are from Paris or Heidelberg. It will just create an account for you, and you will go through some steps of submission. You will get some basic information there. You will describe author. You will describe the data set. You will upload it. You will add the license, then some note, and you will go through some final reviews. And in the end, there will be somebody on the repository side who will check the data if you filled everything correctly, and then publish your data set with the data you put in, or he will return it to you with some and ask you for some changes if it would be necessary, or some improvements. Interesting thing here is the license, which I mentioned, because for this repository they created something called open license selector. When you can ask, or you are asked the questions, what are you wanting to deposit and how you would like to set up the rules. And there are so many licenses, I think more than 50, that it will just limit your choices, or choices you can choose by your answers. So you can generally choose anything from there, but this thing will help you to lead you to the right license. And you can see here that even on this screenshot, you have Creative Commons, which is usually used for works like articles and literally works. And then you have Mozilla Public License, which is used for software. And again, as there is a small notice, because in this area, licensing is interesting and important. You can even add or ask them to add your license, but you have to contact them, and then you will be able to communicate if you would like to do some specific licensing for your data. This repository is also part of infrastructures. This is part of Daria, EU, and Clarin project. It's part of the Czech node of these European projects. And you can see strong connection to these research infrastructures. So it may help you, they may provide you with some more services. In this case of Lindat, they have just bigger ambitions. A repository is just one part of the things they do. So you can, for example, run some services in there. You can run machine translation in this repository. So if you are really from this domain, this is the place you may want to go and prefer it over some more generic solutions. And now we will switch to something completely different from natural sciences. So this will be a short example of GeneBank, which is quite famous, I guess. It's an NIH genetic sequence database of available DNA and other sequences. And again, if you look on it from the perspective of FAIR, which we are talking about, you can see there is some kind of identifier for each record. In this case, is this U49845. Again, similar thing in completely different domain. Reference to article is important here, but in this case, they are not doing it via some via identifier, or they are linking to PubMed, and they have description, which is more like citation. And the third thing here that's kind of helping findability is that they are using some vocabularies for description of the data, and they use taxonomy for an organism. So they have next to this database or this repository, they have a database of organisms from which you can choose specific organism and link it with your data set. So you really know what are you talking about if you are using this kind of vocabularies which are prepared for it. You can see, I hope, that the data have specified well-known format. Well, it's not so much known to me, but I understand that this TC, AG things are very specific, and then people in this domain understand this language very well. And again, this thing allows you to provide some more service, because you know how your data look like. You have some, you are working inside the domain. So you can, for example, visualize part of these segments, and you will describe this part into the metadata, and you can add some more, add some specific service which may be important for people who would like to work with your data, ergo interoperability. And by that, it's everything from GeneBank and Lindat, and I will give the floor back to Jochen, who will talk about institutional repositories.
Thanks. Just a couple of seconds. So yes, in addition to what Milan showed you about domain-specific repositories, I want to finish our presentation with a few words on institutional and other generic repositories, because yeah, on the one hand, you already heard that in principle, of course, subject-specific repositories are the best place to deposit your data, but maybe you work in a field where are no such subject-specific repositories around yet, or sometimes the problem with specific repositories might that they are limited in scope, for example, that they only accept certain data types. So thinking of GeneBank for a second, they of course only accept genome sequencing data, but in your research you might also produce some other kind of data, and maybe you cannot put them to GeneBank because they don't fall into their scope, and you might have to look for other publication venues for this kind of data. And their generic and institutional repositories are also quite powerful tools with regard to, if you want to say it like this or put it like this, with regard to the verification of research data. So I choose our local institutional data repository as an example. So it's called Heiddata. It's the Heidelberg Open Research Data Repository. It's a publication venue for research data for researchers from Heidelberg University. But of course, in the 4EU Plus world, there are other repository solutions around as well. So for example, for the people in Milan, there's also a research data repository available. The University of Copenhagen is in the process of setting up an institutional data repository. And so you should definitely take a look at your local infrastructures providers like computing centers or university libraries or whatever, whether they offer also venues for depositing research data. So also Heiddata could be a venue for making data fair, and I want to show you with a few screenshots what these kind of repositories, what kind of functionalities they offer and how these help to make your data fair. So the first thing is, of course, we talked a lot about persistent identifiers for research data, and that's a basic functionality of data repositories. Typically, for example, you see on this slide a data set published on Heiddata, and you can see this data set also received a DOI as a persistent identifier. And then if you have a look on the respective paper, it's a paper in PLOS or in one of the PLOS journals. You read this paper and have a look at the section on data availability. You can find there that the experimental data and also the in-house developed software for this analysis can be reached via the Heiddata Dataverse network, and then you have the DOI of the data set. And so it's just one click and the readers of your paper can access your data. So that's the first thing, of course, with regard to findability. Next thing is also metadata, data about your data, describing or delivering information and descriptions people need to understand your data. And also maybe information you might need in 5 years from now to understand your data from your current research. So you can, of course, enter all kinds of information like a description here, or you can also enter keywords, and you can also take these keywords from controlled vocabularies. In this case, this example is from the Humanities. So here's the Getty vocabulary used in here, also Library of Congress subject headings. But of course, sometimes also institutional repositories offer very specific metadata functionality. For example, for researchers from life sciences, in Heiddata, you can also enter very specific information on, for example, which kind of organism your data are about and what kind of things. But as I said, institutional repositories typically are generic in functionality, and these kind of things might not be available for all fields of research. So I don't know if people are working in condensed matter physics or in engineering or stuff, they might not find in Heiddata specific metadata fields for their kind of data or their field of research. Publishing data via a repository also is helpful because your data are findable. For example, data on Heiddata can be found in Google Scholar, or for example, also in other databases or catalogs for research data. So on the left side, you can also see a system, for example, it's called the GESIS dataset search. GESIS is a German institute in the field of social sciences, and they run a research data search engine for data from the social sciences. And so also in this specific system, you can find data which are published on Heiddata. The other example here is UDAT, which is B2Find is the name of the service, which is some kind of a search engine for research data on a European level. So that is something belonging to the realm of the Open Science Cloud with some kind of European research data index. Yeah. Of course, data repositories quite obviously help with the accessibility of your data, so you can download public files directly via your browser, like in this example, or also if we are talking about larger volumes of data, you might also download data via an API, because it might not be very much fun to download, I don't know, 100 gigabytes of data via a web browser or things like that. So things like that are possible. And also it is possible typically on repositories to restrict files. So for example, on Heiddata, you can of course have open data, but if that is not possible or not possible for all files, you can also restrict access to data. And like you can see in this example, and people can then file access requests to the data authors, and they can decide on whether they want to grant access or not. Another important functionality repositories might offer for you is something like these kind of private URLs. These are URLs for sharing data sets before the data are publicly released. That is something which you might use during the peer review process for your paper, because you can, via these kind of private URLs, grant access, for example, for editors or for journal reviewers to the data before the data are published, and also before the paper is published. And all these kind of things are then something you don't have to take care of doing. I mean, you have to take care of in the case that you use the repository and you provide the needed information, but you don't have to worry about for example, which kind of metadata standard should I use? So with regard to interoperability, Milan told us that metadata are really important and that there are different standards around. And if you decide to publish your data via a particular repository, they already have implemented these kind of standards. And already, if it's a subject-specific repository, of course, the standards which are really the standards in this particular field of research. On the screenshot, we don't need to go into the details, but you can see that there are a lot of different standards around, which are also implemented in our local solution here in Heidelberg, like whatever you can find, DDI, for example, is the standard of the Data Documentation Initiative, but you can also see that we are able to provide standards for fields like astrophysics and things like that. What institutional repositories typically also can provide is that they come not only with the technical functionality of the repository software, but that typically the maintainers of the repository also offer counseling service and advice, for example, on suitable file formats. So, of course, to have open data, a part of this is also that data should be usable openly, which means data should be available in the best case in non-proprietary open non-proprietary file formats. And here's an example of where the data, as you can see on the top, were provided. It's image data, and they were provided in the CorelDRAW file format. I don't know if anyone of you knows CorelDRAW, but CorelDRAW is some kind of graphic software which provides data in a very ugly proprietary file format. And so what we did here with regard to this data, we helped the authors to migrate them also to a standard vector graphics format in order to make the data preservable also for the long term, because this open format will be preservable and usable also in a few years from now, while CorelDRAW, I guess, won't. Yeah, that was that. And then we come to reusability. And of course, typically also institutional repositories provide open content licenses, which enable reuse. They also typically have versioning functionalities, which are of course important for transparency. So you can see here that there's a data set which comes into several versions, and you can also have a detailed look on what changed from version 2.0 to version 1.2 and things like that. Another thing which is important for reusability is that data come along with provenance information. So with information about who produced the data, also, for example, which software was used to process the data, or where do the data sources from this data set stem from, and all these kind of information can be found in the metadata typically. Documentation files can be provided. That also enhances, of course, reusability, something like a README file and things like that. And yeah, that was the overview about institutional repositories and how they help to provide fair data. And of course, if there's no institutional solution available to you, you can also go for more generic repositories. There are a few services around which offer data repository services to the whole research community worldwide. So for example, there's Zenodo. Zenodo is a generic repository for scientific content hosted by the CERN, and it accepts submissions from any researcher, and you can publish your data there, receive a DOI. Another example would be the Open Science Framework. Also, the Harvard Dataverse data repository maintained by Harvard University accepts data submissions from all over the world. And there are also commercial offers on the market as well, like Figshare, for example, is a commercial research data repository, or a data repository provided by a commercial company. So, and also these kind of repositories provide suitable technology for fair data. Partly they provide even very elaborate functionality. So for example, Zenodo, just to give you one example, has a very elaborate integration with GitHub for the production of research software. So if you develop research software on GitHub, you can integrate your GitHub repositories directly with Zenodo and just push snapshots of your code to Zenodo to make these snapshots not only publicly available, but to receive a DOI for these very versions of your code to make your code persistently citable. This was just one example, but of course, these generic solutions, on the other hand, typically do not provide any domain-specific functionalities, and also they typically don't provide so much individual counseling services. For that, you can typically go to service providers on campus, like research data support units, which provide these kind of counseling services. So that was the typology of research data repositories and their FAIR functionalities. And that's it. So that was the overview and of our presentation on FAIR and open data. I'll try to do a quick wrap up, and then we are happy to open the floor for any questions and for discussions. So I just want you to think back also on the first part, on Paola's presentation, because there we have seen that a proper data management is a primer for the reuse of your data. And reuse means reuse not only by your research community and by academic peers. Reuse also means reuse by yourself in 5 or 10 years from now. That is something which is really an important take-home message. Second one is that research data management is not an extra effort, nothing which comes on top for you as extra work. But at the end of the day, if you organize your research data management well, that will cost less in terms of effort and in terms of money than not managing your research data properly. In order for this to work out, managing data is something you should think of right from the beginning of your research, already when writing a project proposal or making a proposal for a research project. Think about the research data management. Manage your data according to the FAIR data principles. They are not only very catchy, but really a very good formulation of what is the aim of research data management activities. And if possible, then use trustworthy data repositories to make your data available. In the best case, make them available as open research data. Yeah, I think that's the wrap up. We will happily share also the slides via the website of this seminar series. The seminar series will go on in March, where we will have a presentation on open research software. And another event will be on the 4th of April on open science and the role of rights management. And then there will be 4 more sessions to come. That was the overview. And then now we are happy to receive your questions. You can use the chat, but you can also, and we would be happy about that, turn on your microphone and also maybe your camera and just ask us directly. Thanks.
Yes, Jochen, there is a question about the use of a local repository such as Heidelberg or Dataverse Unimi. If it is,
yeah.
If it could make finding data difficult or more difficult, and it is better to use a local repository or Zenodo and so on. I think if you have a local repository and your local repository is interoperable, it is not a problem to make your data findable. If you have not a local repository, so you should or you can use other solutions such as Zenodo. I don't know what you think, Jochen or Milan.
I think I would agree with that to some extent. Of course, if we talk about IT infrastructures of whatever kind, it's always a question of how centrally or how decentrally they should be organized. And of course, in many cases, there are good arguments also to have central infrastructures. I think one important point is that discovery of research data or retrieval on research data management does not need to take place in the systems where the data are published themselves. So we need to take care of having good indexes or research or retrieval systems for research data, and then it doesn't play a too big role where these are published, especially if you think about if research data publication really scales up. I think this will be a task which cannot be handled by only very few institutions. So maybe there need to be different service providers around. I'm not sure whether every university really needs its own system, but it cannot only be the CERN, because maybe in 70 years from now, or maybe in 200 years from now, there will be no CERN any longer. And so I think you need at least some kind of variety there. Anna, did it answer your question? Thanks.
Yeah, thank you very much. Yeah, very good.
I would like to add one more thing. We are in the situation that really the repositories that are really useful are concentrated around domains, and this is things that it will be never centralized as such. So there will be always the problem how to put data from different repositories together, and how people would be searching in them. So it's really doesn't. I don't see a way how this thing can converge into something more centralized. And generally, as we are talking about it, the advantages of this domain or topical way of doing things is they are so great that they are really better than these generic repositories are. And then if you are starting to talk about some decentralized system, you can really put institutions there, and they will tend to take care of their data a bit more always probably than just some generic repository. So I think it's okay, it will work out somehow, and we just need to make this thing really interoperable, very generally.
Yeah, thank you. I didn't mean that to centralize different disciplines. I think it makes a lot of sense to have disciplinary, but perhaps not for each institution, so as disciplinary data are very different, so it wouldn't make sense if each university has one for genetic data, one for economic data, one for linguistic data, and so on. And
of course, also it depends also if you take the analogy to publications. Of course, data and publications are different in many respects, and also there are many problems I think with scientific journals. But what is definitely not a problem with scientific journals is that research papers are not findable because they are scattered around so many different journals, because we have the right systems to make them findable. And also the other thing is, of course, also with regard to publications, there are different solutions around with regard to repositories. For example, in France, we have the HAL repository as a central national repository, and maybe in Germany, we typically have more institutional-like solutions. So, yeah. You have a follow-up?
No, different question. So if nobody else has a question. So if I collect data from individuals or households or firms or so, and then I have the raw data set, and yeah, I cannot publish it because there you can see, okay, this person earned so much money or this firm had so much revenue. But then, yeah, of course, I store the raw data. And then I create an anonymized data set where I remove names, addresses, GPS coordinates, and so on. Am I allowed to make this publicly available because the different individuals are not all identifiable, but it's only pseudo anonymized, because if somebody hacks the original raw data, this person could see then with a who is who, and but if somebody hacks the raw data, then it doesn't really also matter whether the anonymized data is published or not, because the raw data anyway keeps everything. Because sometimes I heard with the GDPR, you're not allowed to publish pseudo-anonymized data. Or do I need to remove or delete in all devices, repositories, the raw data, so that nobody can go back? That's perhaps a question to a lawyer.
To some extent. So, Paola, Milan, any in-depth knowledge on law topics?
Not in-depth knowledge, but yeah, sure, pseudonymization is really important. I feel it that these definitions are vague to some extent, and it really depends. It really needs somebody. Well, there are these data protection officers who take care of these things, and it's something really for them. Because the line, even in specific examples, it's very difficult to say the line between pseudonymization and real anonymization. So it really depends probably on specific example, and needs this DPO to solve this.
Actually, so I mean, I'm not a law expert either, but so to my knowledge, there's an easy answer. The easy answer is if your data are properly anonymized, you are able to publish them. And then the second question, and that's the difficult one, what does properly anonymized mean? And that is not so easy, but part of the answer is if you took a sufficient effort, and then that's the difficult term, to make sure that the raw data are securely stored, then you are fine. And typically if the raw data are stored, I don't know, in some kind of long-term archive provided by the university, and they have some kind of IT security measures in place, then I think you as an individual would be free from any individual legal problems. But that's a non-expert opinion and on the background of the German law as far as I know it. So maybe in Denmark things might be also completely different. So Tarim, maybe?
Hello.
Hi.
Can you hear me? Hello. Thank you so much for the amazing presentation. I just wanted to ask that if these repositories are reliable, are they curated? Like if you talk about GenBank, like it is curated and it can be relied if someone do analysis on that data. But like, are they curated or reliable? So if someone else uses their data.
So I may try to answer again. Nobody's quicker. Yeah, this problematics of trusted repositories, it's really something that's starting, or it's being solved right now. There should be some process in the repositories. There are some certifications, for example, are being developed that it will really, if you would be obliged to put your data into trusted repository, it would really mean that the repository would have to go through some certification that would say, okay, this is a good repository. This process is quite complicated and I'm not sure how many repositories were able to go through this yet, but it's generally, I think it's caused by the like novelty of the topic. It's really something new, and we can expect that it will be more important in the future and in the close future as well. So sure, it's a good idea to look for that. I would expect that we will see it, some kind of core trust seals or some kinds of certification more and more in the future, and it will be de facto standard. And you will be able to recognize which repository is good, and they will aim to get this certification.
And maybe as a follow-up, so I mean, different repositories obviously offer quite different levels of curation. So I mean, as a rough rule of thumb, I would say typically the subject-specific services typically can offer something like that, but of course you have to look at the particular repository and what they do. The generic repositories typically offer no or only very basic curation, so on Zenodo you basically you can upload any kind of files and receive a DOI for that. On the institutional level, it depends. So for example, in Heidelberg locally, we try to do some curation at least but that would be more like technical data curation. So we look at the data with regard to the file formats, whether it's an open format or whether it's a proprietary format, whether we can do or we should do a conversion to an open file format. We also check the validity of the files. Maybe if it's an XML file, we check whether the XML is valid or something like that. But of course, we are a generic service for a campus with 12 faculties or 13 new. We have a 13th faculty here, so we cannot offer any subject-specific data curation. So we cannot look into your code book and look whether you labeled your parameters properly or something like that.
Yes, the same for the archive of the University of Milan. I would add that some of these issues is a matter of the policy of the institution, or for institutional repository. Each institution should have a policy on research data management, and some of these issues are specified in the policy on research data management. At the moment, we are trying to obtain this trusted certification, and I can assure it is not very simple. It is very it's a very time-consuming activity, and it is very difficult to obtain this seal.
I'm from France. I work as a bioinformatician, and I have some short discussions with colleagues who are submitting grants, and now they see this Horizon 2020 about how they should keep their data management for the future of their project. And I can say we haven't really, seriously discussing about any data saving, any repository of something from university. So what do you know about how we could get like a real more detailed protocol of how to help my colleagues to be able to save their data, either their wet lab or bioinformatics, so that the grant application is more detailed and more accepted easily? I
would say, I mean, as always, there's for particular research projects, there's seldom an out-of-the-box solution for everything, but you have to look, of course, on the particular project, on the particular data which are generated and what might be suitable. But I definitely would recommend to contact your local infrastructure providers like Sorbonne University Library, they have a lot of knowledge, and maybe also on the particular services available in France for that. And what definitely is not the case is that your university must provide a local infrastructure for everything, but of course it's also possible to use other data archives, data repositories, and things like that, as long as you provide a plausible account in your proposal. And so I definitely would recommend talk to people from if you are from Sorbonne, from Sorbonne, like Violaine Jacques and her colleagues, because they might be able to offer more specific guidance.
Okay, thanks. So my team is Sorbonne, but they're researchers that they're affiliated with another research institute. I'm in CERM, so it's a National Institute for Health. So it's a mix. That's why it's a bit doubtful where to address for this kind of questions. So if the lab is attached with Sorbonne, they should be able to host the data more globally, or yep, centralized from all the labs that are attached to the Sorbonne.
Yeah, at least they might be able to offer guidance on whom to talk to, and maybe there are also more subject-specific infrastructures available. So, for example, in Germany, we have some kind of national research data infrastructure is built up at the moment, and maybe there are similar things around in France at the moment. And then I think it would be possible to look what could be a solution. Maybe also in the other presentations, we had some information about services provided at the European level as part of the so-called European Open Science Cloud. These might be something to look into for really general infrastructures or services which could be used from European labs wherever they are located in Europe.
I think this is interesting example of this like domain problem, because it's more often people are cooperating across the topic, not just through these institutional levels. So I think the best way would be really to contact local people on Sorbonne, but they can help you and provide you some basic information and tell you what to do. It's really nothing. I don't feel this would be very special, because as people are cooperating in team, even in a national context, it happens even to us that people from different institutions and Academy of Sciences are asking us what to do, because they are cooperating at least to some extent with our universities. So it's like, don't be afraid to ask people on Sorbonne. And generally, if anybody who is still here needs some entry point or some contact, you can look on the pages where you registered on 4U+, and you will see at least one person on each university who is to some extent involved in this research data management topics. And if you need something, you can contact them, or in 3 examples, us who are here, and we can kind of manage to work with anything, I hope, to some extent. So we are quite long today. Do we have any other questions? It was quite one of the longest sessions we had, I think. So in this case, thanks everybody for staying here with us and for listening to us and for asking interesting questions and for your attention. And we hope to see you again in some other 4U+ or specific on our universities presentations. Thank you very much and have a nice day.